Okay, so today we'll go over one from Friday's assignment, and we'll do one from today's assignment, and then you'll have time to work on the rest of the assignment. Yep, that's really it. So easy day. Should be easy day. All right, number 4. So gentlemen, time to pay attention. Look at number 4. Jack, you look at number 4 with us. Let's see. So I have to pick one variable in one equation to solve for, and then plug it into the other equation. So I definitely want to work with the second equation because that's the linear one. I don't want to mess with the quadratic squared stuff yet. So I guess the question is, do you want to solve for x or solve for y?
Y.
And why do you pick y? I think I agree with you. Yeah, that way I won't have to be squaring anything when I plug it in. So let's solve for y. I think that's the better call. If you can solve for x, it'll work. You'll just have to square something when you get there. So it might look kind of ugly. Let's solve for y. So 2y equals negative x minus 2. Oh, yuck. So y equals negative 1/2 x minus 1. Fractions, but that's okay because since it's an equation up here, we'll be able to clear the fraction. So let's plug it in and see what happens. Negative 3x squared minus 4x plus 17 times, here's the yucky part, all of this needs to go in right there. Negative 1/2 x minus 1 minus 5 equals 0. Okay. Yeah. Negative 3x squared minus 4x minus 17 halves x minus 17 minus 5 equals 0. You have options here. You could combine like terms, but why bother? I think I would multiply everybody by 2 and then be done with the fraction. I think that'd be the way to go. I would multiply through by 2 here, then the fractions are gone. Otherwise, you're having to add negative 4 and negative 17 halves, which you should be able to do, but why bother? You want to multiply through by negative as well? I don't like negatives either. Let's do it. I like it, especially since everything's negative. Good call. Let's multiply by negative 2, and then everything will be positive. So plus 8x.
6x squared.
Yep, thank you. 6x squared plus 8x plus 17x plus 34 plus 10 equals 0. Okay, so the numbers are a little bigger. In fact, they're twice as bigger, but there's no fractions. So a worthwhile trade-off, I think. 6x squared plus 25x plus 44 equals 0. Can't divide by anything to reduce, so kind of stuck. No idea if that factors or not. Everything's positive. So we have options here. You could just say, like, I don't want to guess on that. That takes too long. And just jump straight to quadratic formula. I guess you could complete the square, but you'd have to divide by 6 first. And then you'd have 25 over 6, and you'd have to take half of that. And like, ooh. So I'm out on complete the square. I might be out on factoring. 44, a 1 and 44. 2 and 22, 4 and 11, 6, I'd have 1 and 6, 2 and 3, and I got to come up with some way to combine those to make 25. Let's see, 3 times 4 is 12, but 12 and 22 does not make 25. I don't know what it makes, but not 25. 33 and 8, that wouldn't work either.
No, I don't actually think that one. Nope.
I don't think this is going to get me anywhere. 6 times 4, 6 times 11, no. 3 times 2, I don't think I'm going to get there. I don't think there's a combination that works. So, I mean, I can play with it a little longer, but at some point it's just like, you know what, it's not worth it. Let's just x equals negative b plus or minus the square root. Ugh. B squared minus 4ac all over 2a. 4 times 6 is 24. 24 times 44 is almost certainly bigger than 25 times 25.
For sure.
Yeah? I mean, you're going to get a calculator on this unit, so soon enough we can figure this out. But this was 25 squared minus 24 times 44. That's the inside. That's the discriminant. So even if I don't know the exact number here, what kind of number is 25 squared minus a bigger number would be negative, which means I've got negative 25 plus or minus something imaginary. And if I'm looking for, which is fine normally, but if I'm looking for where these two things intersect, I want to know the point that they have in common. They don't. No solution. If we want to be more clear, we should say no real solution. They don't intersect anywhere is another way to say it. So there'd be some imaginary solution, but we don't care about those if we're looking for where they intersect on the real graph. So that was a good one to do because it was ugly in all sorts of ways. Okay, let's do one of them from 7 through 12. Remember, Friday's assignment was 1 through 6. Today's assignment is 7 through 12. Let's see. I have not worked them all, so I'm just going to rely on you. Is there one that you look at? They're all the same type of problem, meaning one quadratic and one linear. So there's no category differences. Number 8 it is. Let's do number 8. Would you like to solve for x or for y? Yes. Let's solve for y. That'll be the easy one. Oh, I haven't done any like this, but for this particular problem, you could work it using a slightly different method. You could do elimination on this problem. Like we've kind of avoided that because it doesn't work very often. But this one's set up.
We should do a different problem.
Do you want me to use elimination on 8? Or do you do a different problem? Let's do elimination. Do you remember how to use elimination? Well, just get rid of it. I don't think that's not really a mathy thing to do.
Exit out.
Exit out. Okay, that's getting closer. Maybe. What would allow me to exit out or get rid of it? Combine them. I'm going to add the two equations. And maybe it's a little weird because usually in elimination everything's lined up. And we don't have that here, so I need to be careful. But I am going to add the two equations. So negative 2x squared minus 20x. The y's cancel out. Minus 50 equals 0. Just a little side note. If we had substituted with y equals 1 minus x, we would eventually land at the same spot. So it's not, I think it's a little easier on the front end, but eventually we land at the same place. I think I would divide by negative 2. X squared plus 10x plus 25 equals 0. So that's a nice one. X plus 5 squared equals 0. X equals negative 5. That's a double root. I don't know that matters for this particular problem, but it's a good thing to start kind of recognizing when that happens, because that does have meaning in some places.
Mr. Wolf, I have a question.
Hold on, what's the question?
Technically, could we just multiply one of the equations, like on 9, could we multiply the bottom by a negative and then do elimination?
Yes.
Cool.
Back to this one. X is negative 5. I need to plug in to get y. So it turns out I have to solve for y anyway. Y equals 1 minus x. So y equals 1 minus negative 5. Is this an acceptable way to present my answers? No. What is the acceptable way? An ordered pair. So that thing intersects at negative 5, 6. One intersection rather than two. That makes me think that it's not makes me think. It's a tangent line. Again, you don't have to know that, but that double root was kind of a hint that it might be a tangent line thing. The question, especially for the video people, that was asked off camera there was, what about number 9? Could we use elimination for number 9 if you multiplied through by negative 1? Yeah, definitely. So you can use elimination. It's rarer that it works easily. But if it shows up, by all means, help yourself. Okay, so again, Friday's assignment was 1 through 6. Today's assignment is 7 through 12. Peeking ahead, tomorrow we'll start word problems. Wednesday we'll have a quiz. I'll be gone Wednesday, but our test isn't until next week, so we have time. If you need to make up the last test or retest the last test, this week is the deadline for that, so let me know. It's not many of you, but if it's you, let me know and we can fix that.